Okay, first topic on the agenda is from Nithya. It's a tracker issue about bucket logging.
Yeah, hi everyone. So I'm as the tracker issue states, there is a problem with bucket logging if the log bucket is on an EC pool because a, the log records are appended to the Rados object, and that doesn't work for EC pools unless you turn on a particular configuration option, and that causes the performance to drop. So one of the solutions that Yuval and I have been discussing. We plan to we are planning to, in case the log bucket has been created on an EC pool, we plan to use something like the multi-part implementation where it puts the data in the extra data pool, the metadata. So we're planning to do something similar, and I'd like to quickly run through what we're thinking of and ask for feedback and if there are any issues that we might run into. So to start with, we are writing the log records to the extra data pool, which is a replicated pool that is created. So step one was doing that in the code. But that also means that you have to update the head object which is actually created on the EC pool, to point to the tail objects on the extra data pool, which means we need a storage class. So as part of that, what we are planning to do is require the user to create a storage class to point to this said replicated pool and use that. And we need to somehow provide that storage class as part of the bucket logging configuration. With this approach, we are doing it in stages, and right now I'm working on a POC to see that this works. I'm currently writing the log records to the extra data pool and the head object to the EC pool. What I'm doing right now is, for the POC, is to hard code a storage class. I've called it bucket logging, and we require such a class to exist for this to work. The storage class is because if we don't have that in the data in the manifest, the get object will obviously not work for the log record object. So that's stage one. Eventually, we plan to copy that data from the extra data pool to the EC pool when the log record is finally committed. So the way it works is, currently it creates the tail object first, keeps appending to that, and then once the log is rolled over or committed, the head object is created on the EC pool for the bucket. Yuval, have I covered everything, or have I missed anything?
No, this is great. Thanks.
Okay, so does anyone see any concerns with this approach, or is there an easier way to do this?
I'm a little confused about the need for a storage class, though.
So what I see based on the code is that the in extra data field for the object is not stored on disk, right? So it is basically an in-memory setting that is just applied to all metadata objects before it tries to get the placement data for that. That's part of the multi-part implementation. Now, if I don't have a storage class, there's no way to point from the head object to the tail object in a different pool. At least that's my understanding. Is there another way? So what happens is, if I just write everything to the extra data class, which is what I tried earlier, I just hard-coded the code to set in extra data to true and then get the placement, and it writes everything. But then if I try to, once I commit the log object and then I try to get the object, right? I try to do an AWS S3 CP or whatever, it can't find the tail because there is no mapping between. It tries to find the tail object in the same pool as the head object. The head object is created on the EC pool. and it can't find it. So that operation fails. So that's why we need the storage class, because that is what actually points to a different pool for the tail. So does this approach seem valid, or is there some kind of gotcha that we might run into later? Because this is still very much a work in progress.
I mean, maybe we could avoid the need for a storage class by teaching the manifest, if it doesn't know already how to refer to object names in different pools. Don't think that we want to create a storage class that points at our data extra pool and be able to write other objects in there.
I mean, the storage, if we move the ownership to the user to set up the storage class, then they can just also set up their pool, the pool for the log objects. So, I mean, in this case, they have to set up everything. But going back to what you asked, is there a way for the get object to work without a storage class? Like, how would we know that we need to take it from this extra data pool? This is just a regular object.
The object manifest would need some information to steer it to the right pool, yeah.
But that's kind of changing the manifest mechanism, right?
So the storage class information is saved in the manifest right now. That's what we're using. It's the tail placement field. But that only takes a storage class name.
The AWS feature, does it support storage classes also? That sounds generally useful.
No, the AWS feature. So the only reason we need this, like in theory, you should create the log object on whatever storage class that you think the log should be in. This is like the level of freedom that AWS have to the user is that they create the log object on whatever storage class that they want. We have a problem that if for some reason the storage class that they selected for the log bucket is an EC pool or points to an EC pool, then because of the way, the specific implementation that we have, that won't work because we cannot append to objects on an EC pool. So the end goal, I think, would be to use this extra data pool only as temporary place for the objects, and when we're committing them to the bucket, copying them over to a different object actually in the EC pool or whatever place the log bucket is in. So I honor the configuration of the user there. The problem is this copy could take time and could introduce delays to the system, so the copy has to be asynchronous. It also has to be persistent, and this introduces quite a bit of problem, or no problem, but the implementation is not trivial. We want to get there, but now we have a system that doesn't work in some setups, and we want to have a faster and simpler fix for the issue before we actually do the asynchronous copying.
Right. Once we get to the point where we do the asynchronous copy, we no longer need the storage class or manifest changes.
So, I mean, the feature is released in Tentacle and is considered complete, but it has this limitation. And we want to be able to have a fix for this quicker than the end solution.
Feels to me like a little bit like this creates extra technical debt that's quite low level and persists for longer than we would want. I mean, is it really objectionable? I mean, what is it? Is it really not an option to just do the fix correctly and get it in, backport it to the appropriate point, release some tentacle when ready?
I mean, to be honest, that makes sense, especially if
feel comfortable with that.
No, I mean, the initial thought was to use this extra data pool internally without the need to expose that to the user and have a quick fix and later on have a better fix, but this would be transparent. I guess if the solution is not transparent, then yeah, we're just creating some debt here. So we'll have to kind of probably live with the limitation that doesn't work in some cases and provide a proper fix.
At least I think that would be my vote.
I tend to agree. I mean, having a kind of a temporary hack that is exposed to the user is not a great thing.
Fair enough. So shall we just proceed to work with getting this copied asynchronously? And that's probably going to take some time, though.
Yeah, I mean, in the meantime, we don't support log buckets on EC pools. This is kind of a limitation. But I mean, I get what Matt is saying. Like, let's say that we change the manifest or we require the user to add something, and then, you know, maybe in another point release on Tentacle, we tell them, oh, by the way, you don't need to do that. That's a bit of a hassle for the users.
True. Not to mention if they have different versions of RGW running on different things, that might cause issues as well, right?
Yeah.
And then what?
Could be. I'm not sure that we have a version issue, but regardless, if this is something that the user has to do some work to get it done, and it's not completely transparent as a stopgap or a hack, then yeah, I agree with Matt. It's not a good idea. We should just live with this.
Okay, then we can drop this particular stage and move on to the final solution.
Yes, we should be able to. I mean, we should be able to use the extra data pool for the objects when we create them, right? There shouldn't be any need for a storage class or anything for that, right?
Right, because at that point, until the head is committed, we can just keep writing to the extra data pool. And before committing, we'd have to copy it over to the actual EC pool and then create the head.
Yes. And that's all would be also nicer as we're going to honor the setup in the sense that if the user thinks that the log bucket should be on an EC pool, then it should be. Temporarily, object could be off of the EC pool, but eventually they'll be piling up in the EC pool.
Okay, then I guess we have a consensus on that.
Yeah, I think Casey, you have another opinion here.
I guess I'm not 100% clear on the design here. If the bucket's on a replicated pool, are we still copying on commit?
I mean, this is actually a question. I mean, if the bucket's on a replicated pool, we can know that and we can avoid this whole process. We can even recommend that. I mean, That would create two code paths for the whole thing, which is not ideal, but that's going to be much better, like from performance perspective, because there'll be absolutely no special issue with the.
So another question that's probably out of left field, but it's hopefully not a herring, like a salted cod question, I guess. But is this stuff exposed through SAL? Or because this could, I mean, or conversely, I guess the real question is this? I think it isn't. I think I already know the answer to that. But is any of this meaningful? The server access slugging and is it a generic feature? So how will we in future deal with the cases that aren't just Rados and are not and apply generally?
We have a SAL API
Okay.
for that. And most of the code is above the cell level, like most of the bucket logging.
Okay, this is great. Okay, then I withdraw that. Thanks. That's a good answer.
Sure.
So sorry, going back to the replicated pool case, we would still be appending to log objects in the extra pool or some other pool, the replicated pool?
I mean, the original idea was to if the bucket log is on a replicated pool, then just create the object there and append there, and the commit phase doesn't do any copy. Just put something in the bucket index and create the head object, and that's it. I think it's a better solution. We can also say that overall performance would be better if you use your log bucket on a replicated pool, but it's not mandatory. I think the drawback with this approach is that we have two different code paths, like one for replicated pool and one for EC pools, and they're different. So, but it's like more code, but I think it's better.
Okay, so we don't need a way for the manifest to point at different pools. Is that the conclusion?
Yes.
Gotcha.
I mean, one thing that we may do as maybe a preliminary step is to do the copy synchronously. In case of
with respect to workload.
Well, okay, so the copy can happen in two cases. One case is where somebody is calling flush. That could be Redis Gateway admin, or that could be an API that calls flush. Now, if that takes a couple of seconds, there's no issue because this is a very infrequent command. Like you would call flush maybe a couple times a day. So doing stuff synchronous there is not a big issue. The big issue is when the committing or the flushing is happening implicitly because of the time that we want to limit the amount of time that the logs are pending. And this is happening lazily just upon writing a record that can result from any operation. And that is pretty bad if this would happen synchronously, because somebody is doing, I don't know, a get object, or maybe get object is not an issue because it's only standard one. But in general mode, maybe they do a put object or a very small object, and under the hood, synchronously, we're copying 180 megabytes of log objects.
And it doesn't feel right to invent that. So yeah, I agree with you. So let's just avoid that square.
Yes. Okay. Yeah. Okay. So we'll do the async copying on commit.
And I assume that you've solved the race conditions, like from multiple writes that notice that a flush is needed.
Oh, this already exists. I mean, we already the potential race condition already exists, even today, right? Because we don't do the copy, but we're still doing, like, we're updating bucket index, and we're creating a head object. So all that stuff already exists, and all that stuff could have races. The way that this is handled is that the name of the pending object is in a special, like, object that we have for the bucket, and so the name is the current name is there. So if somebody thinks that they need to do a flush, the first thing that they do is they generate a new name, put the new name, and then they go on and do the flushing. And if somebody else is also thinking that they need to do a flush, they would read the new name. Maybe it's an empty object by now because it was just created by the other client, but this is still fine.
Okay, thanks. If it's async, you might have problems with crash consistency or error handling, such that if a copy doesn't complete, then we would orphan the tail objects and not have a reference to them. So something to think about. Maybe the object that points at the current log head needs some extra info about in-progress flushes, I guess, with some recovery logic.
Yeah, maybe to be able to do some cleanup, I guess. I haven't thought about that, but we should be looking at that.
Yeah, that's a smart comment.
I mean, even today it can happen because, like, what if, I mean, we're doing bucket index update and the head object creation, and they can fail as well. I mean, less likely than the copy, but it can still fail. And I don't think that we have cleanup in those cases. But for sure, with the copy, that would increase the chance that something goes wrong. Kind of related, I have another question of something that we ran into when we did some large-scale testing. We saw that sometimes objects that were already committed to the bucket were deleted or kind of gone. They moved to the GC list for some unknown reason. We were not deleting the objects or anything. And a strange thing that I saw is that when I'm running the orphan list tool, they detect the temporary objects as orphans. So my question, do we have some kind of a background process to clean up orphan objects? Because that might just delete some of our tail objects unnecessarily.
Not automated, no. There's tooling to be able to search for them. And if you're adding new objects, you want to make sure that the orphan tooling doesn't identify them as orphans. So we might need to, I forget which command it is, like bucket rados list maybe, is supposed to enumerate all of the object names expected in a bucket. Eric would be the one who knows most about that.
Okay, I'll check with them because I think the way that we create them actually are exactly as orphan object because we create them before we create the head object. So, and later on they fit into the head, which means that they just look like tail object without a head. But we do that in the reverse order. So this is why it might be an issue. I'll follow up with Eric about that.
In terms of things being improperly GC'd, though, if you're writing updates to a head object, I don't know if that's the case, then the do write meta will optionally enqueue the tails for GC. There's a keep tails flag that might be relevant there.
Okay. I'll check that, or Nita, it'd be great if you can look at that.
Are there cases where you're committing a head object and making it visible, but then writing changes to that later, like X headers or something? Or are you just committing and not writing to it again?
I don't think I write to that again, but I need to look at the code that creates the head object. Maybe there's something that I'm not doing correctly.
Okay, unmute is finally working for me. I'll take a look at it as well.
Okay, thanks.
All right. Sounds like we've made progress. Any more on this topic?
Not for me. Yeah, that was all.
Thanks, Nithya. Thanks, Yuval. Next up is Jane asking about status of bucket listing. I'll link the associated tracker also.
Yeah, this is a closed PR for an issue of a bucket. Sometimes bucket listing taking a very long time for a bucket index that have like a large number of contiguous delete markers. We recently got some bucket listing problem in our clusters, and we think this is one of the contributing factors. So, but this PR is closed due to lack of activities. So I'm wondering if it's being worked actively by somebody, or like what are the expected changes for this PR?
So I did discuss the design quite a bit with the author there, and I was preferring a different design. There's some discussion about that referenced.
It was last year, yeah. Okay, list op, right? That was your comment.
Yeah.
Okay.
We're still tracking the issue, and Eric assigned himself to it a year ago, but has been, I think, busy with ordered index work. So if anybody is interested in picking this up, Eric and I would be more than happy to assist there.
Okay, cool. So just to make sure Eric doesn't have any local changes on this, he's not actively looking at this. So before, probably one of us will take this.
Correct. Yeah. He and I were going to discuss the proposed design when he gets around to it, but that hasn't happened yet.
Okay. Okay, got it. So yeah, we'll see our priority. Probably one of us will take this, and if we take this, we'll probably reach to you offline to talk about to discuss the design.
It'd probably be useful to involve Eric too, if you can. But I don't know. I don't see how it affects anything he's currently working on. But it maybe it's something he wants to think about.
Yeah, sure.
While working on new stuff.
Okay, sounds good. Yeah, that's all from me.
Great. Yeah. So the general idea is to prevent the client from timing out by sending white space over the socket while we're still waiting. And that way our listing can be more efficient by preserving the markers in between instead of responding to the client and then coming back with a fresh, starting from a fresh position.
Okay. Yep, we'll look into that.
There's also some places like RGW Lifecycle where we do long listings internally, and being able to keep all of the state over that entire listing would make it more efficient also. All right, so I mean, if you want to continue discussion, maybe the closed PR would be a good place to do that, just so that all of it's in the same place.
Yep, or read the PR first to understand more. Then we can discuss.
Sounds great.
Thank you.
Okay, any other topics? All right, let's call it then. Thanks all.
Thank you.
Thank you.